Hello, this is Steve Kimbrough, and this is also part 2 of the briefing on the Asadai project, which is a text mining project taking place here at the University of Pennsylvania. To review very briefly from part 1, there I emphasized 3 principles: concept scoring, which is the idea of identifying a concept and a document, and of developing a score, which is an association, maybe more than one-dimensional association between the concept and the document. Second was concept representation. Just how do we represent these concepts? And I indicated that some complexity would be needed, although we did not discuss how that was done in particular. And third is the principle of categorization. We build what we call categorized document bases, in which we take a simple collection of documents that's undifferentiated, and we also identify a taxonomy or categorization scheme. We map that to the document base, and therefore we have for each taxon in the categorization scheme a list of associated documents. So these are our basic building blocks, and the subject of this little talk is really the question, what can we do with these building blocks? What kind of systems can we get out of them? I'll start with a discussion of a demonstration system that exists and is online on the web and so forth, and I'll go through it pretty quickly in the interest of time. And my main point here in this slide is to compare and contrast it with what you get when you interact with a typical internet search engine. So 1, 2, 3. The first thing you need to do is to pick a database that will be categorizing. Here the database is a collection of documents that pertain to the subject of oil and gas services pertaining to mining. So that's what's indicated on the title of the database. Normally with a search engine on the internet, you just get the documents that the search engine has collected. You don't really have a choice. Some of them will give you some choice, but that's one point of contrast. The second point is indicate your concept. Well, here the concept representation is quite conventional. It's just what you get on an internet search engine, and so the concept is represented by the words moisture and barrier. Third, something that's quite different is to pick a taxonomy, and in the system will give you multiple choices, and you can see that what's been picked here is again unspec. So we're going to take these documents pertaining to oil and gas services in the mining industries and map them to this complete unspec taxonomy or categorization scheme, which has, as I said earlier, about 20,000 products and services in it. Now if you click on the button Run Query, this is what you get, or the top portion of what you get. These are the top level concepts or categories of the unspec classification system, and they've been ranked here in descending order by the degree of match between our query and the documents collected under these categories. We can now drill down. I've circled in red to indicate that we're going to drill down on medical equipment and accessories and supplies. So now we see underneath another set of categories, which is one down in the taxonomic hierarchy. And we'll click on wound care products. We'll click on bandages and dressings and related products, and we'll get down to dry dressings, and we'll click on that, and that's the end. So that's the bottom level. It's a leaf of the unspec categorization system, and in this case we happen to have 2 documents associated with it, and you can click on cached to see the document as we've stored it. It won't have the graphics and so forth, or you can go to the original URL and hope that it's still there, and at least you have information about who did it. I'll give 2 more examples quickly and schematically. This slide is you should recall a similar slide from part 1, which gives the schema of the Asadai process. Left to right, bottom to top. The texts for this, we can think of them as regulatory filings, SEC filings. We can think of them as coming from newspaper articles and news sources such as Factiva and so forth. The taxonomy would be an example would be the Wilshire 5000, which is a list and indeed a taxonomy organized by industries of about 5,000 companies, actually around 7,000 companies. And the third element is the concept, and again we'll allude to the environmental sustainability concept in my comments, that you don't want to just type in environmental sustainability, you need a more complex representation. Here we assume that that is underneath, it's there. You feed all of this into the matching engine, and the matching engine produces a report. So in the southeast corner of the screen, you see in schematic form a simplified version of the report. It needn't be quite so simple, but the simplicity here serves the purpose of communicating the basic ideas. So we call this report a scorecard. In the left column you see example companies from notional companies from the taxonomy, and in the two columns you see the positives and negatives. So these are two aspects or sub-concepts, if you will, associated concepts with environmental sustainability. So positives indicate concept representation of positive things that are in favor of environmental sustainability, and negatives are things that are contra environmental sustainability. And of course we're interested in both, and there could be, as the dots indicate, other aspects, other facets of this rather subtle and complex concept that that would be representative, would be represented, and that the matching engine would pick up, and that our system, our scorecard report would report on. The second example is also the running example of Tyvek and looking for new uses of it. Our texts here are things like patents, web pages, corporate archives, and so on. We could have many different taxonomies, but for our purposes, present purposes, I think unspec is appropriate. A taxonomy of products and services. And finally, we see the concept is Tyvek, and we're looking at different attributes of it, or if you will, different clusters of attributes. And we feed it into the matching engine. We get the scorecard report is indicated in the southeast quadrant here. And on the left-hand column, you see notional examples of products from the unspec taxonomy: shoes, ships, sealing wax, cabbages. I guess kings would be next. And I like to use this notional example because it reminds me that the counterpart of floor wax is not sealing wax, so that's helpful. Anyway, once again, we see there are at least two important facets or aspects of the Tyvek concept that are important, that have been represented, and that the scorecard reports on or displays information on. And one is related to moisture. Tyvek is a moisture barrier, water barrier, liquid barrier, etc. And the second is its thermal properties and its operating properties under different temperatures, which turn out to be important for its application. And the idea here, once again, is you get numerical scores on these different facets, and they're matched to potentially several thousand, even tens of thousands of different categories: shoes, ships, sealing wax, and so forth. And the size of the score and the pattern of the score provides the information that would surprise you and lead you to follow up with further investigation. So it's a system for delivering interesting leads. Think of it as a system for qualified leads. In general, what kinds of applications can we have with these kinds of building blocks? Well, as I've emphasized, I like the word scorecards. It's become a popular term. Many organizations are engaged in doing this, whether they're NGOs or governmental organizations, commercial firms, etc. And broadly speaking, the concept is you develop a scorecard like what we've seen for performance rating, perhaps on multiple dimensions, of people, of products, of firms, of agencies, you name it. An interesting application of this kind of thing is in supplier risk management. You're a large firm, you have several thousand suppliers, these suppliers have their own suppliers, etc. And you need to do environmental scanning and monitoring for risks that would appear in the environment that would cause your supplies to be disrupted. And these could be natural disasters, construction projects, strikes, new laws and regulations, etc. And this itself is a form of competitive intelligence. You'd like to know about what's going on in your industry, about changes in what's going on in your industry, about industries that affect your industry, and so on. As I've indicated or hinted at least with the discussion of Tyvek, I think there are many potential applications of this technology for new product development. The Tyvek example is just again a simple example of the sub-problem in new product development of finding new applications for existing products, particularly component products such as Tyvek and in general things that go into other things. And finally, an important area would be litigation support, and in particular the discovery process, in which law firms need to look through thousands and typically even millions of documents to look for patterns of information. And here these patterns can be revealed by the kinds of things we're talking about, such as categorization and careful matching and scoring and complex concept representation. A cliché in technology is that technology X is limited only by your imagination, and although it's a cliché, I think it's often true, and I think, in fact, it's true here. That said, there are lots more things to discuss, more research and development to be done, and I've indicated some prominent areas on this slide, and I'll leave that subject for another time. And I'll conclude with this. The slide more or less speaks for itself, but we're excited, we're moving forward. The opportunities and the work to realize those opportunities are huge, and we certainly welcome inquiries, and we do seek partners. Thank you for listening.